Yeah, welcome back. All right, so we want to look at a paired t-test in past, paired t-test. All right, so this is a parametric test, all right, for dependent sample, all right, dependent sample in past. This is basically based on the one numerical and the one paired sample data. Call it paired group, the one paired group, and this is a dependent sample PAT test which is used to compare the means of two related or dependent samples. Two related or dependent samples. And don't forget this is a time-based. PAT test is time-based. What do I mean by time-based? You have before and after. Okay, you perform the experiment on the same subject or the same group of specimen before and after. Just for example, maybe you want to do experiment on the impact of vacation on people on the impact on people's stress level, for example. Okay, maybe some staffs in an organization want to know what is the impact of vacations on their stress level. Maybe before maybe you select only 20 staffs, for example. Before they go on vacation, you check their BP, okay, their stress level. You check their BP before they go, and on vacation after they travel on vacation, maybe after 1 week they return back. You now check their BP again to know their stress level, and you now compare the difference. You now have before and after. So the same BP you check, the same specimen you check their PP, the same specimen you repeated again second time. So no difference. So it must be the same specimen, the same number of people, okay, the same individual. All right, you do it 2 times before and after. Or maybe you want to compare, want to know, does the diet program have effect on the body, for example, okay, on the body weight of the people. All right, you want to know if diet, maybe you want to organize a diet program. Maybe you select 10 people, 10 specimen or people, and before the diet, you observe their weight, you measure their weight and record it down. So after the diet has been administered, maybe within for few months or maybe 2 months, 3 months, then you now check their weight again and see the difference to see if there's any statistical difference in the weight of the people. The same thing applicable to the vacation, the stress level. Maybe it's an statistical difference in the stress level of the staff based on the vacation day after. So these are just a good example. So we are looking at we look at mice now, for example, mice. So we want to look at, we tested the mice first. We checked their weight before we introduce our experiment, before the experiment. So after the experiment, also we now also check their weight after again. So we have 2 data now for the same specimen, 2 data, 2 weights, the before weight and after weight. So this is a concept of for PAT test. All right, PAT test. So we are going to look at that quickly, how to perform that. So want to know if there's any statistical difference in the mean weight of the mice after their treatment. After treatment, you want to know if you have the mean weight. So we are going to do that in part. So there are 2 ways to do that. Actually, you can just say do this. Okay, this of course you have a group. The first group is what before. Second group is after. But PAST does not really recognize in this format. Okay, it recognizes in this format. So before and after. All right. So that is how PAST recognizes it. So you can just you want to see your before and after data together. I want to see like this. So, but in HAR, you can do this in HAR. I recognize in this format. All right. So I'm going to first use this one to test for our what they call it, our Shapiro and the rest. So let's first copy this now and take it to PAST and test to see if it's significant. So we have this now. I can just paste here as usual, because this time around we don't need so we need the group. Let's say we use the group, okay, and then we run it. So let's just select it together now to test if they are significant. We have 20 subject now, 10 before, 10 after. So let's just go to univariate and click on normative check. All right. So before and after, you can see before and after. Then we have Shapiro test 0.2, 0.28. So this is a past Shapiro test. Okay. Then we can also check for also normality. What do you call it now? Okay, for outlier now, outlier. All right. Outlier. So outlier pass as well. You can see one. See no significant outlier for each of them. All right. So for multiple also you can look at it. No significant outlier. So which means it passed the outlier test. So we can go ahead and do this and use this one for PRT test now. All right. So let's compute that. But before we go, don't forget that you don't use this method to compute. You just use to test. Okay. So for you to compute, let's just open a new blank one. Then we copy this. This is what we use. Okay. In parse recognize data to be separated. Okay. So it separate the data. So we click here and we paste here. All right. Paste. All right. So remove this. So these are the two things we need in parse to do that. So we can also use this one also to do the Shapiro test. Okay, it doesn't matter. So you see, you do that the same thing. All right. So you can just click on here. All right. See, give you the same result before and after. Okay, so that's no problem. Or you can do the same thing for normality check, but then we have to do one by one. Okay, you come here, you do the same thing. Normality check, outlier rather. You can see no significant outlier, no significant outlier. So the same thing with the second one. So that is that. But let's quickly do our PRT test now. We select the two together, these two columns. That is what a pass needs, right? We go to univariate, okay? We go to univariate, go to two sample test. We now go to two sample peer tests, all right? We click on it. All right, so you can see. So what we need actually is this part. Okay, that's what we need, this part. All right, we need this part. All right, this is what we need. Only this part. So we don't need other ones. So now that's it for now, at least for now. So it gives us the mean 195.3, and therefore before and after 392.255. We need the mean because rather the mean is 199.16 and 393.65. That's the mean, right, of each of them. Now our t-test mean difference is 194.49. All right. So, but your t value is minus 20.883. All right. So, and the p value for that is 6.2 times 10 to the power minus 9, which is highly significant. So, but the permutation of it, which means multiple tests of it, in permutation format, is also give you 0.001. So, which is also highly significant. So, this is our result now. We can conclude that this is significant result. So, we can say that the mean there's a significant difference in the mean weight of the mice after treatment. So we can conclude in that way. So it's very easy to conclude like that because our result is significant. So it means that when we finish our experiment, the mean weight is highly significant. So we can say that there is a significant difference in the mean weight after treatment. So, for example, if it's for vacation, you tested, for example, the stress level, the PB of the staff, you tested, you can say conclude that okay, there's a significant difference in the stress level of the staff after vacation. That's as simple as that. That's as we conclude. Okay. So the same thing with a diet, or when you test the diet of the people. So that's just a simple way to perform a t-test. T-paired sample t-test. So I will see you in the next class. Thank you so much for listening.